Hello and welcome to the webinar titled Technology Diversity in an Age of Uncertainty, presented by Lumen. Hi, my name is Dave Lovelace, and I'm your primary presenter today. The original webinar took place on February the 17th, 2021, and this is a recorded event as a follow-up for people who are unable to attend the live event. So thank you for showing your interest in this topic, and I'm certain you will find value in the information that we're going to be sharing with you throughout the webinar. I'd like to start off by introducing the Tennessee dedicated account team. First off, we have Levi Loans, who is the account director located in Nashville. He is partnered by Jason Bruce, who's the account director located in Knoxville. And then they're supported by the lead solutions engineer, Andrew Roselle, who is also in Nashville. And then Bill Sapitsaris is the team director responsible for the state. Hi, once again, my name is Dave Lovelace. I am the Strategic Client Solutions Director covering the SLED East region, the state and local government East region. And I would like to invite anyone interested to please reach out and connect to us on LinkedIn. We would certainly love to hear from you and connect with you. So in today's topic, the agenda that we'll cover is going to start off with Lumen's perspective on the fourth industrial revolution. Then I'm going to follow that up with identifying the threat to our business operations. Then we're going to go into some operational best practices, which I'm sure a lot of you are already engaged in. And then we're going to focus on business continuity strategies and how we keep our operation running through technology. And then we'll support that discussion with going into some details about technologies that support diversity functions. And then I'm going to share with you some information about your options for procuring the services offered by Lumen. And then at the end, I'll tell you about a free session that we're offering for all state agencies in Tennessee. So from Lumen's perspective, when we talk about the fourth industrial revolution, we believe that it's a time for amazing things. If we look at the evolution and advancements of technology, we understand that the steam engine changed the world. Then came along electricity, and with that, the silicon chip, and the world has never been the same. And now comes the next great step for civilization, the fourth industrial revolution. So we are on the edge of this next great advancement in technological change. In this new world, data is the new currency. The success for governments and enterprises in this new world depends on the three A's of data. Governments, enterprises, and businesses must be able to acquire data, analyze that data, and then act on it. It is becoming a critical part of the way that we operate our systems and in the way that we run our businesses. And just as we have all experienced in this profession, as we move through these changes, civilization is becoming increasingly dependent on those technologies or on just technology in general. But as our dependency on technology grows, of course, so does the threat. The pandemic changed the way that we work almost overnight. In fact, I know at Lumen, when we went to a work from home posture, we literally did that almost overnight. And in this new world, remote work went from being just that convenience to being a mission critical requirement. We've certainly all have had our shares and experienced natural disasters before, and they certainly offer a really big threat. Sometimes we can see them coming, and sometimes we can't. And even if we think about the advanced warning systems that we have in place for things like storms, tornadoes, and other types of events, I mean, there's really only so much mitigation that we can do in those very short period of times that enable us to be able to respond to disasters. And that time of response is certainly a critical factor in our ability to provide business continuity. Adding to this list, acts of terrorism is certainly a real threat. If you go back to what happened during 9/11, all the way up to the most recent events in Christmas of 2020 in Nashville, we know that those risks are real. The threats are real. Sometimes they're foreign, sometimes they're domestic. And then some risks are higher than others. And not only do they impact the way that we operate technology, but it also causes us to rethink the way that these threats can impact technology. And then wrapping up this list, cyber attacks are certainly a real threat. In fact, it's a continuously evolving threat. And the worst thing about cyber attacks is that the bad actors only need to be right one time, whereas IT managers and security professionals need to be right all of the time. In this presentation, I have included a link to our annual threat report that is published by our cybersecurity research center called Black Lotus Labs. Lumen, as one of the largest global tier one ISPs, we see a tremendous amount of the world's internet traffic. And we use this visibility to learn about the threats through work done at Black Lotus Labs. And then as a result of that, we publish an annual historical report and make that available for all of our customers. I would encourage anyone that's interested in this type of data to check this out. It's an easy read, and I'm certain that you'll find it useful. And so this list is certainly not a complete list, but when I look at this list and I think about these threats, it reminds me of a quote that I think most of you should recognize. That quote is, "Everyone has a plan until they get punched in the mouth." And I think that you can probably think of who that came from. Yep, you guessed it right. It was Mike Tyson. And when I think about all of the threats on the previous slide, I certainly think that when they hit us, it absolutely feels like a punch in the mouth. So now that we've covered a list of things that, for the most part, we can't control, here's a list, maybe not a complete list, but a list of the things that we can control. As IT professionals, this is where we show and create value for our users and our customers. This is where we're managing the infrastructures that create the capabilities that all of our users depend on. I like to use the analogy that our systems and infrastructures are like vehicles cruising down the highway at 70 miles per hour, and it's our job to change the tires without stopping the car. Unfortunately, for us, end users actually take IT for granted. In fact, it's a challenge for us to protect them from the complexities that are involved in making the technology function flawlessly. In fact, to the user base, it's really all magic. Basically, if our end users don't know we are there, then we've done our jobs well because I know we're making changes, running upgrade projects, and keeping things up to date without missing a beat. Although I would add, as leaders and decision makers, we are kidding ourselves if we think nothing bad is ever going to happen. In fact, it's inevitable, and it's our job to minimize the impacts when things happen. Next, I'm going to get into some operational best practices for you to consider. So this is a list of common activities that I'm sure all of you are already doing to prepare for a disaster. Your planning is the framework and the governance to manage disaster preparation. It includes getting support and sponsorship from leadership and goes beyond just the technical functions of our systems to also include personnel, real estate, vendors, contracting, utilities, etc. In, in this planning, your documentation is key. This is the foundation for your plans. It will include things like runbooks, operational governance, and other policy documents that will enable personnel to respond at the time of disaster. More technically focused is the engineering and design aspects of your systems and technologies. In fact, this is where we depend This is what we depend on for supporting our operation, and this is where we're going to focus most of the discussion in this webinar from a high level. If you're not an engineer or that technically inclined, there's no cause for concern because our content was developed to cover a very wide audience for the purpose of this session. Next up is in testing. And I emphasize that testing is important. I think this is self-explanatory. We need to build our systems, build our plans, and then test them. Create your DR plans and test them. Additionally, the human element needs practice for at time of disaster responses to create the muscle memory necessary in order for your plans to be effective. I cannot emphasize the importance of testing enough. I think you get the point. Finally, remediation. We need to review our plans periodically, and especially after an event occurs. Basically, be a learning organization and be disciplined around remediation. Let's face it, trying to come up with every possible scenario that we have to prepare for is a pretty overwhelming task. So we're going to review some concepts to approach these ideas in more easily digestible chunks. So the first thing we need to do is define priorities. And personally, I struggle with the word priorities as a plural word because priority is really something singular, but we all know that we're dealing with multiple priorities. On the other end of the spectrum, we certainly cannot make everything a priority because when we do that, we essentially make nothing a priority. So we need to find some balance. This is why you should start with the top 2 to 3 most critical applications or functions that are the most important to your operation. Focusing on a smaller list allows you to build a foundational plan that will provide lasting risk mitigation for most of your infrastructure. For your applications, are we talking about a CRM or a database or an ERP app? Maybe it's a web application that is cloud provided. Is there a specific function that relies on technology that is deemed critical? Maybe that could be a voice system or a contact center environment. Basically, once you have identified the critical functions and the critical applications and built a plan around these critical applications and functions, then you're going to have a foundation for protecting the less critical applications and functions, right? So you eventually have to categorize everything, and how well your plan supports the top 2 to 3 applications or functions are going to basically provide a foundation that supports the rest of the lower priority applications and functions in your environment. It's basically a really good springboard for developing the rest of your plan. And one thing I want you to keep in mind, I'm not suggesting that you should ignore less critical functions. I'm simply expressing this idea as an approach to the planning in a thoughtful way that allows you to accomplish a very overwhelming task. As you're making your plans, the information that you gather and formulate needs to be documented based on these 2 topics: business continuity and disaster recovery. And I wrote verses in the title because it's important to understand the difference between the two, because it's this difference that impacts things like budgets, run books, and defines your policies. So business continuity is a focus on keeping the business running. It might include resources running in a limited capacity. It could be alternate or secondary technologies. Maybe you have a backup internet connection that is a smaller capacity than the primary, and it's just good enough. Or maybe you have an application that is so critical that there is no such thing as just good enough. And I think you can see how this begins to paint the picture of how it influences or impacts the budgets for providing business continuity. Then we talk about disaster recovery. This is how you get things back to normal in response to the disaster or at time of disaster event. It includes getting systems back online, gracefully failing back to primary systems, maybe activating or reactivating vendor services, and everything else that is required to bring these things back to normal or that graceful fail back to the primary. Something else to consider is that after a disaster, whatever learning you go through during that disaster may actually redefine a new normal. Just as we've learned from the work at home requirements that we're in today, that pandemic has created essentially a new normal, right? I don't think that we're ever going to go back to exactly the way that things used to be. When it comes to BCDR plans, both are individual and both are necessary, and they need to be combined to create a fully comprehensive plan. And then finally, understanding the relationship between these two, the better that your business continuity plan, the quicker that your DR plan is going to help you get back to normal. Next up, let's take a look at some business continuity strategies and specific concepts. I'm going to start with this architectural drawing of the evolution of network architectures. This is actually a computer science conceptual representation of a system architecture. All the bubbles here could represent any element of a system where all of the outer elements have a dependency on a single element of the system. Without that single element, the entire system fails. For networks, it could be a primary data center, or for an application, it could be a single server. Whatever the system, the single point of failure creates very high risk. Next up is the decentralized architecture. This architecture represents the ability to operate on islands. Groups of functions might eventually rely on a single function to operate perfectly, but this concept represents the idea that certain elements will continue to function in some capacity when there is a failure. This architecture offers less risk and could be appropriate for some systems. It clearly has flaws as well. Finally, we have the distributed architecture, where most functions are not impacted by a single failure. This is a complete departure from the monolithic nature of older technologies. Applications today run on microservices or containerized systems in virtual environments, and networks are built with full mesh capabilities, and our options for creating resiliency continues to evolve, as does our dependency on these services. Another technology that continues to proliferate to support this evolution, that is also a major focus for the Lumen platform, is edge computing. In fact, we've just recently stood up our edge computing node right there in Nashville, Tennessee. And so edge computing is focused on bringing the decision making for applications as close to the users or endpoints as possible, where the milliseconds for making those decisions is the most important thing. So think about IoT applications and autonomous vehicles as good examples of the advancement of applications that rely on this distributed architecture that will need to leverage edge compute in order to function properly. Now, let's get into some more tactical network design concepts regarding network and circuit diversity. So from a service provider or ISP perspective, these are the types of diversity that are the most common elements or options provided to customers. Obviously, any single points of failure will drive up your risks. And this is where you need to calculate the trade-offs between the impacts of an outage versus the costs to mitigate the outage. As you move down the list, your risk is going to be decreased and your costs are going to go up, with the highest cost essentially coming from the duplication of all network resources. Now, let's go into these a little bit further and take a look at them in a bit more detail. So on the right, the drawing is to represent a circuit entering your building, right? And when we're talking about circuits, we're really talking about the cable or the fiber and the path that it takes to get from your building to the service provider. This may or may not be on diverse paths. Of course, if you don't have path diversity and you add it, then your costs for circuit diversity begin to go up. This kind of diversity could also be achieved with wireless technologies like LTE or 5G. LTE is certainly an appropriate technology when we talk about branch level connectivity, but and that's because it has its challenges and limitations with bandwidth, which of course those improve with 5G, but 5G has distance limitations and you may not even have these options when it comes to your more rural markets. Overall, circuit diversity is going to be on the lower end of the cost spectrum, and it comes with the least amount of risk mitigation. Next up is pop diversity. So this is improving on circuit diversity by providing the service from two different service provider points of presence. Of course, if you have circuits that use the same physical path, at some point, then pop diversity may not be as effective. Certainly, if you can have your last mile connection on diverse paths, then you're improving your overall risk profile and getting better value for the dollars that are being spent on the diversity design as a whole. And so, a key element that is really important to understand here as you're spending your money on these types of diversity is that not all last mile access is treated the same. I mean, it's trivial to say that physical path matters, but last mile services that are provided by especially Metro E networks has a fault that is often not understood until a failure occurs. You could have diverse paths to a building that are provided by a Metro E service that eventually all goes back to the same ILEC central office Metro E switch before they carry your traffic to the separate service provider POPs. It's a terrible scenario that I've seen so many times in my 25-year career that you, as a customer, you think you have diverse service, and then you find out that there was a single point of failure because you were relying on a single technology for last mile access. It's an important thing to talk about with your service providers, and it's something that Lumen has a lot of experience in understanding so that we design networks with the proper levels of diversity. So with pop diversity and all of the design elements to consider, you can understand how your costs begin to go up while you're also mitigating your risks even further. And then the final scenario we have is carrier diversity. With this kind of design, you would consider everything we already talked about in the design for the previous two items, except for you're adding two different carriers. So there are certainly some very complex elements that are necessary in order to support the operation of this design. And in this design, you are essentially duplicating everything, and the high availability functions in the hardware are critical. Not only do you need to provide dual routers, but you also want to ensure that the other functional elements like firewalls are operating in that high availability or HA mode so you don't experience any downtime due to the failure of a single piece of hardware. The amount of money that you spend in services for this type of diversity would absolutely be wasted if you do not also include the HA functions of your hardware in the solution. And of course, this design has the highest cost, but it provides for the most risk mitigation. And this is the design that you're going to find in your primary data centers and sometimes some of the most critical headquarter elements of your buildings, your infrastructure, and your users. And then, you know, but I always get this question, we don't have endless budgets to build two of everything. And of course, we know that. So that's why I'm going to focus on technologies that support diversity functions. So it's important to look at the problem in a different way. We need to kind of flip the script on this problem, if you will. Certainly, if all of your technology lives in a single building and everybody's in that single building, I mean, your users have access to everything that's in that building. But if your operation relies on connectivity outside of that building, then you're going to have to build two of everything on the network edge to ensure the proper level of reachability and risk mitigation. But when you can take certain functions and begin to leverage the features and capabilities of those functions, then you have the ability to create highly available architectures and avoid the high costs while doing so. So let's take a look at each one of these in a little bit more detail and talk about how they support business continuity needs. So dynamic routing. The simple definition for dynamic routing is that it is a function that enables a router to pick the most optimal path, that being a network path or layer 3 of the OSI model. And these decisions are based on real-time logical network status. So in practice, if I have two logical network paths to choose from, let's say two different circuits to reach the same destination, then my dynamic routing protocol is going to use real-time information to determine the path to send my traffic to the destination. So Border Gateway Protocol, or BGP, is used to provide gateway routing between networks. This is why it's used on the internet edge of your network to provide routing access to multiple ISPs, and it is in fact a requirement to support that diversity function for automatic failover to an alternate ISP. And I'll add that the configuration of this is very technically intensive. It has a lot of requirements, and you're going to employ a highly skilled individual to be able to set these things up. Additionally, you have Open Shortest Path First, or OSPF, which is a common standards-based interior gateway protocol, or IGP. OSPF is going to be supported by all router manufacturers, and that's an important point because I know that another protocol that you may have heard or that you're used to is EIGRP, which is found in your Cisco environments. I'm highlighting BGP and OSPF protocols because this is where you're going to find, or this is what you're going to find in your SD-WAN environments from a layer 3 perspective regarding capabilities with those appliances. So speaking of SD-WAN, let's go on to our next technology. So SDN or SD-WAN, software-defined networking, in its simplest terms, is the separation of the network control plane, so the brains of a network, from the underlying physical network that is used to forward traffic. Well, why is that important, you ask? So let's talk about some of the advantages. So first of all, SD-WAN is network carrier agnostic. The reason it's carrier agnostic is by decoupling the control plane, where all of the decisions are made, from the actual forwarding plane, which is just the physical network, that underlying network simply becomes an option for an SD-WAN enabled device to forward traffic. It also allows you to combine expensive private networks like MPLS with secondary internet connections like low-cost broadband. The reason it's carrier agnostic is that SD-WAN builds tunnels over all of its network connections to create this fully meshed architecture between appliances on the network. And so remember our network architectures, that fully meshed or distributed architecture? Uh, that distributed architecture allows you the greatest survivability or reliability for the network to support the most critical functions. And then the other element, which is cost, right? So again, it lowers your cost because now you can use low cost broadband as an option for building the primary network or just creating the diversity or alternate paths for that network, or supporting direct access in a secured way to cloud resources directly from that distributed environment. Additionally, With with SD-WAN, the technology has OSI layer 4 through 7 visibility, which now allows you to dynamically route traffic based on more than just layer 3. You can route it based on application behaviors. So a great example of this is voice over IP traffic. So the SD-WAN service can monitor things like latency and jitter to make sure that you're meeting specific thresholds overall in order to provide the best path for the voice traffic to ensure a proper level of QoS. It can literally monitor the levels on one option, and if it sees them degrade, select the other better option in order to enable and support that quality of service. Next is virtualization, which really allows you to run SD-WAN on almost any x86 supporting device or inside your cloud native resources. So now we can take the idea of cloud and really make that an endpoint or a virtual location on our distributed network, creating the highest level of not only accessibility, but also reliability and the most agility for network efficiency so that your end users are no longer hairpinning back to primary data centers in order to reach cloud applications. And then finally, of course, when we think about creating this larger internet presence in our networks, we have to make sure that it's secure, right? So SD-WAN comes with that enhanced security, that fully enhanced security or integrated security. And when you think about the tunnels, it's actually creating IPsec tunnels and using encryption to ensure that traffic integrity across your network. I'll wrap this up by saying SD-WAN is absolutely a very complex topic, and we would certainly welcome any additional conversation that anyone would like to have around that topic. So next up is the session initiation protocol, or SIP. So think voice over IP, which really could mean IP trunks to your premise-based PBX as a PRI replacement, or it could be services provided by a cloud-hosted voice over IP PBX. I know with most customer engagements that I have, especially in the public sector, voice or collaboration is included in that top 3 priority functions list. And when we look at voice over IP, something very interesting happens that we need to consider. And that is when you have a voice over IP enabled network, and that network is optimized to support the diversity of your business continuity of your voice over IP traffic, then you're likely creating the foundational network infrastructure that can enable business continuity for all of your other applications. It happens all the time. It's also part of the reason in business continuity plans that IT professionals put their voice over IP systems in those top 3 priority lists. Additionally, when it comes to SIP, your service provider service infrastructures are geodiverse and redundant by nature. Additionally, they provide you with lower cost designs and capabilities that are inherently highly available with those platforms. I like to think about when the pandemic hit and we all went to work from home, the physical PSTN trunks and voice services that were going into our buildings either became not usable or very complex in order for us to use them or even leverage them in those environments because all of our users were working home from collaboration platforms like Teams. Uh, Additionally, the way that those architectures are structured, it also supports the ability to provide high availability for that critical function and do so at a lower cost. Because when you build highly available SIP architectures, even though you're creating multiple trunks, the billing mechanisms for supporting those services are based on the number of simultaneous users, and it doesn't matter how many trunks you build to the platform. So not only does it help you increase your business continuity capabilities, but it also allows you to do that while driving down costs not to mention that SIP in general will drive down your long distance costs overall. Then finally, we have cloud native solutions. The great thing about cloud native solutions is that they're purposely built to be highly available. This is one of the supporting reasons why more and more applications are moving to the cloud. Certainly, the term cloud is probably the most widely used term in technology, which I don't know if that's true or not today, but I do know that everyone has a different perspective when we hear the term cloud. For the purpose of this discussion, what we're talking about is the public cloud. And I want you to think of it as any service that is provided to you via the internet. And when we talk about public cloud, there are certainly a lot of versions of that: public, private cloud, clouds that are built to support different compliance requirements for state and federal agencies. But essentially, it's anything that you reach not on your premise and via an internet connection, right? When we think about applications they're no longer centralized or based on those monolithic architectures. In fact, they can't be. They are now based on distributed architectures and leverage microservices so that companies can use DevOps models to rapidly deploy features and capabilities in their environments. The primary focus for developers is this ever evolving enhanced user experience, which must include reliability and high availability. At Lumen, we have quite a few examples of these services because our hosted voice platform, our SIP platform, and our network-based security platforms are built on these architectures with all of these things in mind. The other thing about cloud native solutions that becomes important is that API enablement. It is the ability to integrate the functions of those applications into the operational systems that you rely on to keep your business running and to drive more of those efficiencies while also reducing the costs and the overhead to run your systems and to achieve your business results. And then the last one is cloud native solutions typically are pay as you go, and they focus on that OpEx model from a usage base instead of that CapEx model, which certainly is much better on our budgets. So what are your options? It brings me to this slide, talks about how we support the state of Tennessee today. So you have quite a few things that you can choose from. And I will say that we work with state procurement to continue to evolve the options that are available to you on these purchase vehicles, not just the state, but also on federal contracts like the GSA Schedule 70. So starting up, we have the Lumen long distance toll-free state contract, which includes long distance toll-free conferencing, SIP services, and IVR. We also have the NASPO participating addendum, which has all of our networking products, as well as the security to go along with that and software-defined wide area networking. And then on the right, we have the GSA Schedule 70, which is just too big of a list to even mention what's on there, but it basically includes everything, as well as the MICTA contract, which is also similar to the GSA Schedule 70. And so this slide is a quick representation of the 4 pillars of the Lumen platform. That is adaptive networking, edge cloud and IT agility, collaboration, and connected security. And across all 4 of these pillars, we provide managed services and consulting. Those can be, off-the-shelf managed services for any of the products that you see here, or it could be something that's more advanced and built custom based on your specific needs. The items highlighted in yellow are the items that are on the NASPO contract. The items highlighted in blue are the ones that are on the long distance and toll-free contract. And certainly we invite you to come to us with any conversation about any of the products in our portfolio. We are here to be consultants to you, to help you consume solutions and functions as a platform-enabled service rather than just taking individual items off the shelf. We know that your needs can get to be very complex, and we're here to support you. With that, I'm going to move to our next to last slide and share with you the offer that we have for everyone that has participated in this webinar. We are offering a diversity design workshop. It is a free 1-hour session that we are offering to you. You're going to receive an email with instructions on scheduling your workshop. And during the workshop, what we'll do is evaluate your diversity problem, your needs, any business objectives that you want to achieve. And then we're going to offer you options and solutions to help you mitigate your risks. In those sessions, as we prepare for them, we'll ask you for some information depending upon what the topic needs to be about. And then we'll reach back into our organizations to make sure that we bring the proper thought leadership into the meeting so that we can provide you with the most value. So also on this slide, you see the contact information for Jason Bruce and Levi Loans. Again, I invite you to reach out to us, connect to us on LinkedIn. We certainly want to hear from you and look forward to working with you. And so to wrap up our webinar, I want to say that we know what it takes to serve state and local government. In fact, we have a dedicated practice that is led by this team specifically in Tennessee, but certainly other teams throughout the rest of the United States. And all of those teams operate under the hashtag Serve the Mission. Hashtag Serve the Mission is, in fact, part of our culture and our DNA. We know that you all have made a choice to serve the public, and we want to make sure that we can support you in that mission. Lumen has the people, we have the technology, and then we rely on these guiding principles to help you serve your constituents. So with that, I'll wrap us up by saying thank you. Thank you for your time. Thank you for your business. And we look forward to talking with you all during your consultation session. Thanks and be safe. Have a great day.